Right then, question 2, quarks and leptons. So the positive kaon, K+, has a strangeness of +1, as all kaons do. Which of the following is the quark composition of the positive kaon? I won't write the table out, it's one that we're just going to have to learn or use the hexagonal diagram to try and work out. It will be the up anti-strange. It may be easier just to memorise some of these quark configurations for mesons. We can eliminate, of course, the two baryons, the up anti-strange, the anti-down strange. So that would limit our options a little bit, and then we can work out the charge on the other two to work out what it should be. Part B, we have a kaon, positive kaon, that's decaying into a muon, positive muon, and a muon neutrino. And we need to show that lepton number is conserved in this decay. So let's do it's called the BLQ table. So that's your baryon number, your lepton number, and your charge. We just want to look at lepton number. So the lepton number of the K+ particle is not a lepton, it's a hadron, it's two quarks, quark-antiquark pair, so its lepton number is 0. The muon has a lepton number of -1. If we don't know that, that is actually on the formula sheet, so there's a table there, we can work it out. And the muon neutrino has a lepton number of +1. +1 minus 1 equals 0, so lepton number is conserved. Part 2, show or state a quantity that is not conserved in this decay. That will be strangeness. If we do another table down here, strangeness of the positive kaon is +1. Neither of these two particles have none, so strangeness. In fact, strangeness is the only quantum number that cannot be conserved. So that tells us that this must be some kind of weak interaction. Okay, part 3. So we've got a table here, and we've got to put in the correct classifications for each particle. First column's been done for us, so those are both charged. We can tell that because of these little things here. That's fairly easy. We want to fill out the rest of the table. So looking at the first one, looking at this one here, it's a meson. A meson is a hadron. Baryons will be 3 quarks, so it's not a baryon and it's not a lepton, so it's just those two ticks. For the muon, which is charged, it's not a hadron, it's fundamental, it's not a meson, nor is it a baryon, it is just, sorry about that, it is just a lepton. The muon neutrino, again, that is just a lepton with opposite lepton numbers. Part C, the positive kaon can also decay to form a pion and one of the particle X. Deduce the identity of X, the mystery particle. So K+ will go to pi plus X, whatever X is. And we can work out what properties it must have by doing a BLQ table. So the baryon number, first of all, well, K+ is a meson, so it's not a baryon. That's not a baryon. So the only way this could be true is if I had a baryon number of 0, i.e. it wasn't a baryon. The lepton number is the meson, so it has a lepton number of 0. The pion has a lepton number of 0, so it must also have a lepton number of 0. And then the charge is a +1, and the pion has a +1, so in order to conserve charge, particle X must have 0. So we can say not a baryon, not a can't be a lepton either, and its charge must equal 0. So it must be a meson, it's the only particle left that we can have, and the particle, a meson with a charge of 0, that would be our pi 0 particle, which is our answer.